Swayam Prabha. Digital India. Educated India.
Good morning and welcome to this next lecture on vibrations of plates and shells. Last time we derived the Gauss Codazzi relations. However, in the process of deriving, I needed T12, okay, and for finding T12 I used this relation which is T22, but I did not derive T22. So, I just took it. So, today we will derive T22. Okay. So, the root will be, we will derive T11 and T22, T1 comma 1. 1 comma 1 and T2 comma 2 using T1 comma 2 and T2 comma 1, but these are derived using a different route, different method. Okay. So, there is no circularity. It is not that I am using T12 to finding T12 using T22 and deriving T22 using T1. No. So, we will first now derive T11 and T22 using a different set of T1 comma 2 and T2 comma 1. Okay. So, let us see. So, T1 comma 2 and T2 comma 1. Okay. We will do it from R bar. Okay. Now, R comma 1 2 is equal to R comma 2 1. Okay. And we know that R comma 1 into T1 is equal to A1 T1 is equal to the vector R comma 1. Okay. Similarly A2 T2 is equal to R comma 2. Okay. Now, if we use this, okay, then this differentiated with 2 is equal to this differentiated with 1. Okay. So, what we get is A1 T1 comma 2 is equal to A2 T2 comma 1, which is equal to R comma 1 2 is equal to R comma 2 1. Now, if we differentiate or carry out the differentiation, A1 comma 2 T1 plus A1 T1 comma 2 is equal to A2 comma 1 T2 plus A2 T2 comma 1. Okay. Now from here I can get T12 or T21, which is what? Let us say T1 comma 2 is equal to 1 by A1 A2 comma 1 T2 plus A2 T2 comma 1 minus A1 comma 2 T1. Also T2 comma 1 is equal to 1 by A2 A1 comma 2 T1 plus A1 T1 comma 2 minus A21 T2. Okay, this is different. This is a different formula for T1 comma 2 and T2 comma 1 arrived at from R. Okay. Now, how to get from here T1 comma 1 and T2 comma 2. So, I will just show one of these. Okay. So, now we have T1 as a unit vector such that DT1 is perpendicular to T1, right. And what is DT1? DT1 is del T1 by del alpha 1 d alpha 1 plus del T1 by del alpha 2 d alpha 2, that is DT1. Okay. So, now if we draw a picture, this is alpha 1, this is alpha 2. Okay. So, T11 will lie in the N and alpha 2 N and alpha 2 plane. Okay. It cannot have a component in T1 direction. So, del T1 by del alpha 1, which is T1 comma 1, okay, is equal to Cn plus DT2. Okay, so we have to find C and D. We have to find C and D. Okay. Now, if I dot this with N, so N dotted with T1 comma 1 gives me C N dotted with N plus D N dotted with T2, N dotted with T2 is a 0, so this gives me C. Okay. So, this C I get from here. Next, T2 dotted with T1 comma 1 okay, is equal to C T2 dotted with n plus D T2 dotted with T2, which is equal to D. Okay, so D comes from here. Now we know that T1 dotted with n equal to 0, okay, and therefore T1 dotted with n differentiated 1 also 0. So this is equal to T1 dotted with n comma 1 plus n dotted with T1 comma 1, that is equal to 0, okay, which means what? And this is my C, okay. So therefore C, which is equal to n dotted with T1 comma 1 is equal to minus T1 dotted with n comma 1, which we know, okay. So this is equal to minus A1 by R1. We have derived this before. Next, T2 dotted with T1 is equal to 0, and so its derivatives are also 0. So T2 dotted with T1 comma 1 is equal to T2 comma 1 dotted with T1 plus T2 dotted with T1 comma 1, okay, and this is my D. It's still 0, so that my D now is equal to minus T1 dotted with T2 comma 1, okay. This T2 comma 1 is a new T2 comma 1, so this is equal to minus 1 by A2 A1 comma 2 T1 plus A1 T1 comma 2 minus A2 comma 1 T2 dotted with T1, okay. So T1 is perpendicular to T2, and T1 comma 2 will be in the 2 direction. So this and this dotted with T1 will go to 0. So only this one will remain. So that my D is equal to minus A1 comma 2 by A2, okay. Thus what do I have? I have now T1 comma 1, okay. Now T1 comma 1, which is this now, okay. I have found C and D. So my T1 comma 1 is equal to minus A1 by R1 n minus A1 2 by A2 T2, okay, and T2 comma 2 is equal to minus A2 by R2 n minus A2 comma 1 by A1 T1, and this was used in finding the new T1 comma 2 and 2 comma 1, okay. What were those? These are components of this actually. So this plus this will be 0 if you can try this out. So the new, using this, the T1 2 and T2 comma 1 I write here. T2 comma 1 was 1 by A2 del A1 by del alpha 2 T1 and T1 comma 2 is equal to 1 by A1 del A2 by del alpha 1 T2. You can see these are the first terms of the new values. Okay. So this long formula was used to derive T11 T22 and T11 T22 were used to derive the short formula. There is no circularity. Just one thing I want to remind is that we will be dealing with shells of revolution. Shells of revolution. Okay. And if you have a shell of revolution and the meridians and parallels are taken as the coordinate directions, then they are the principal lines of curvature. And therefore M is 0. Okay. For example, we have seen it for a cylinder. So if we look at it for a sphere, okay, in the sphere there is this axis and there is this meridian that rotates, revolves around it. This is the meridian, half circle. Okay. So if we take one coordinate along this and the other coordinate along this, okay, then they form the principal lines of curvature. And so one radius of curvature is thus just the radius of the meridian, which is in this case r. Okay. The other radius of curvature is the intersection of the normal with the axis of rotation, the distance. Okay. The normal is coming this way, or normal is coming this way, and it intersects the axis at the center, and that also is equal to r. So both r1 and r2 are equal to r for the sphere, and these are the principal lines of curvature, and M will be 0 for this case. Okay. So now the next stage is here. We have so far looked at the distance between r at alpha 1, alpha 2 and r at alpha 1 plus d alpha 1, alpha 2 plus d alpha 2. That means we are just looking at the middle surface. Okay. So there is a shell of revolution, I told you, and then there is a middle surface. Okay. And around which there is a thickness. We will be dealing with shells of uniform thickness. Okay. So, this is the middle surface. This is the middle surface around which there is a thickness. Okay, there is a material around the middle surface that makes up for the thickness or solidity. So, R now refers to a point on the middle surface which has coordinates alpha 1 and alpha 2. Okay. There is something to be said about a valid surface or a developable surface, which I will do in the next class. Okay. It is related to the Gauss Codazzi relations we derived. Okay. But for now, let us proceed this way. Okay. So, on the middle surface we have a point at alpha 1 alpha 2, then a little distance away we have another point, and we found that distance squared to be a1 squared d alpha 1 squared plus a2 squared d alpha 2 squared. Now, it is not sufficient to have this only on the middle surface. Okay. So, now let us say I expand around this. This is the middle surface and this is the thickness. So, there could be a point in the material thickness, okay, along the coordinate, along the normal alpha 3 distance away, there could be a point. Okay. So, now we have to account for that point from the origin. So, let us say it is there, that point, and another point a differential distance away within the material. So, that means we have a point which is R at alpha 1, alpha 2, alpha 3, and another point R at alpha 1 plus d alpha 1, alpha 2 plus d alpha 2, alpha 3 plus d alpha 3. Okay. So, now what is the distance between these two? Okay. So, we can write R, the big R, in terms of our small r, which is on the middle surface alpha 2, plus we move alpha 3 distance into the material in the direction of the local normal, which also depends on alpha 1 alpha 2. So, with this definition, what is dr? Dr is obviously dr plus alpha 3 times dn, okay, plus n into d alpha 3. Okay. So, dr we know from earlier, dr we know this. Okay. So, what is dn? Dn is del n del alpha 1 d alpha 1. D alpha 1 plus del n by del alpha 2 d alpha 2. Okay. So, that is, so this part is known from previous situation, this part we just wrote, and n is the local normal, we move d alpha 3 in the local normal distance, okay, direction. Now, I will just clarify one thing pictorially. So, if we say that this is my alpha 1 and this is my alpha 2 direction, this is my alpha 3 direction, okay. And let us say I am looking at a point here, okay. So that is small r, this is the middle surface, alpha 1, alpha 2, and the local normal direction is here, okay. So my this point is alpha 1, alpha 2, alpha 3, and this is my big R, okay. So now I move certain distance in the alpha 1 direction, certain distance in the alpha 2 directions. This is my dr, this is my dr, okay, this part, that part, okay. Then I move alpha 3 times dn, okay. So n is the local normal here, okay, and a change on that is dn, and so n plus dn is the new normal, where at alpha 1 plus d alpha 1, alpha 2 plus d alpha 2. So it is a new normal. That means what? This also should be unit normal is equal to 1, okay, and therefore dn changes have to be in the alpha 1, alpha 2 directions, okay. So if we move dr distance right here and then we have alpha 3, let me change this, alpha 2 is here, then I have my original normal direction like this, and let us say this is alpha 3, then I have to move a certain distance del n del alpha 1 d alpha 1 in the alpha 1 direction, then I move in the del n del alpha 2 d alpha 2 alpha 2 direction, is a bit exaggerated, let me shorten it this way and that way. So I am here now, okay. So this dr plus that is alpha 3 dn, then further I do original n bar d alpha 3. So original n bar is this direction, I do d alpha 3 in a small amount, okay. So now from here to there is the dr, or from here to there is r bar of alpha 1 plus d alpha 1, alpha 2 plus d alpha 2, alpha 3 d alpha 3, okay. So that is the pictorial version of it. So now if we have to do dr dotted with dr, okay. So first we will get small dr dotted with small dr plus alpha 3 square dn dotted with dn plus d alpha 3 squared plus twice alpha 3 dr dotted with dn plus twice alpha 3 d alpha 3 n dotted with dn plus twice dr dotted with n d alpha 3. Okay. Now we know that n and dn will be perpendicular to each other. Okay. A change on the unit normal and the original unit normal. So this is perpendicular to each other, so this goes to 0. Similarly, dr happens to lie in the mid plane, okay, and n is the local normal. So this is also 0. These two are 0. So we have these terms that survive 1, 2, 3 and 4. These 4 terms survive. Okay. So now let us look at the second term, which is alpha 3 square dn dot dn. Okay. So alpha 3 square, okay, let me sort one thing out. So first one which is dr dot dr is a1 square d alpha 1 squared plus a2 squared d alpha 2 squared. Okay, that is there. Then the second one is alpha 3 squared dn dotted with dn, which is equal to alpha 3 squared del n by del alpha 1 dotted with del n by del alpha 1, okay, d alpha 1 squared plus del n by del alpha 2 dotted with del n del alpha 2 d alpha 2 squared plus twice del n by del alpha 1 dotted with del n by del alpha 2 d alpha 1 d alpha 2. Now we are in orthogonal curvilinear coordinates, so this and this are perpendicular, so this goes away. So we are left with these two, and from our original earlier derivation we know del n by del alpha 1 dotted with del n by del alpha 2, okay, into alpha 3 square d alpha 1 squared, sorry, is equal to alpha 3 squared a1 by r1 squared d alpha 1 squared. Similarly, alpha 3 squared del n by del alpha 2 del n by del alpha 2 d alpha 2 squared is a2 by r2 d alpha 2 squared. Okay. So let's term 2 here. Let me write it. Term 2 here is alpha 3 squared. These are positive anyway, so a1 squared by r1 squared d alpha 1 squared plus a2 squared by r2 squared d alpha 2 squared. that is term 2. Okay. So, we are running out of time. So, let me stop it here. We will continue from the next class.